everyone, my name is David and today I'm going to start recording this video. What if we nuke the moon? What would happen if we detonate a very powerful nuclear weapon on the moon? Would the explosion knock the orbit towards the Earth, causing tidal waves and misery? Could the moon be destroyed, showering Earth with a rain of meteoric death? During the Cold War, the moon was a major target for space exploration and, military bases. So the U.S. Air Force commissioned a serious study into the effect of a nuclear detonation on the surface on the moon. But just quoting stuff is boring. So let's conduct a very important scientific experiment with an imaginary 100 megaton thermonuclear, about twice as powerful as the most powerful bomb ever detonated. We'll also place a number of curious astronauts around the moon as observers. Let's push the button to slow down time. For the few milliseconds, nothing much happened outside of our weapon. Meanwhile, inside, high explosives sent a shockwave to a radioactive metal core, compressing it so much that it reaches the singularity and starts nuclear fission chain reaction. The first 100-degree plasma created in the first stage of sets off the second stage with atomic nuclear fusing like they do a core star. Very briefly, our weapon contains the hottest place in the universe, and only now, barely 10 milliseconds later, now the rest of the universe find out that anything happened, and suddenly, bomb dissolves and a flaming star of a nuclear death is born. So far, so good, but everything that happened now is very different from what we use on to Earth because no major difference. There's no atmosphere. As the fireball shines, release a flash of X-rays, thermal photons, and burns everything, which rushes out of and within 50-kilometer radius as leech. But on the moon, without an atmosphere and oxygen-rich air, there's no burning at all. Also, there's no things to burn. The crunchy top soil of the moon is made from silicate rock and metal screwed to just dust and eons of netherite minerals impact, mixed by tiny traces of water. When heated by the explosion, the X-rays from the fireball vaporize a thin cloud of rock from the lunar surface, while the unlucky dust, that's what the fireball melts into glass. Any astronaut watching between about 50 kilometers can expect it to be fried. And now we begin to see one of the biggest differences between explosion in space and on Earth. On Earth, the atmosphere fights back against the plasma bubble. Its expansion is violently stopped within moments with pressures of the atmosphere. But this is not good news. As the fireball ramps the atmosphere, it produces the most destructive part of a nuclear explosion. On Earth, shockwave compresses the air around the explosion, rushes out as fast at the speed of sound, shattering buildings and roaring so loud can rupture organs. But on the moon, there's no shockwaves. No atmosphere means nothing impeded the expanding explosion. In space, on the moon, the fireball just grows and an eerie silence. There's no atmosphere to stop it or give it a voice. This would be an amazing thing to watch from a safe place. distance. Unfortunately, there's hardly any safe viewing distance for nuclear explosion on the moon. Without an atmosphere weakening the deadly ice and radiation that can scramble DNA, anyone close enough to get a good look will be exposed into fatal amounts of radiation. But of course, that's not all. While all this happens, the explosion hammers against the moon, transferring about a tenth explosion energy into seismic waves, powering an intense moonquake. The moon is much smaller than the Earth, and our astronauts will feel inescapable bones shaking no matter where they're standing, compared to an earthquake of 7 on Richter's scale. The shaking could seriously damage level infrastructure that we might build on the moon. Who hit the far side on the moon will have no idea it's an explosion. A quaking would feel like an astronaut the size of a great pyramid has struck. And it's not over yet. When our bombs explode, the ground shakes, splatters like water when a rock strikes a point. Explosion pushes against the surface. It may excavate much more a million cubic meters of dust and rocks, forming a crater kilometer across white bedrock, supposedly into a rubble. The debris is shot into the sky at every direction. Again, without an atmosphere, there's no dragging to slow down of any of it. Much of the debris scattered and never returned to the moon, flying off faster than escape velocity. 30 of micrometeors have been cast off to explore the solar system. Down on Earth, though few will be larger than pebbles. Any satellites, astronauts, or space station will though have a really bad time. Meteorites are launched at many speeds and angles, allowing them to spread all over. Like bullets, they punch through our curious astronauts, no matter where they stand. Finally, our explosion comes to an end. On Earth, firewall rises from a air balloon, and forming a sort of stalk at its reach up, a cooler air is drawn around it, rounding the top of a mushroom cloud. But on the moon, well, you know by now, no atmosphere. So no mushroom. The larger the plasma gets, the cooler it becomes, the less energy it has to make interesting or terrifying things happen within seconds pulling the trigger. The bubbles dance and fades from view. It will be visible from Earth, like a star flickering to life, but only fade right away. A spark and then nothing. The cloud. Tiny debris reaches far above the surface of the moon. Is illuminated by the sun for a few minutes, giving the eerie beauty for anyone left to absorb the spectacle. What about the moon's orbit? Well, it's basically unchanged. Trying to move a moon with the nuke is trying to move a truck by blowing on it. Nuclear explosions may be big, but space is bigger. Our mighty explosion just leaves another crater, one amongst millions. Still, anyone on the moon will continue not enjoy themselves. The material that ends raining raining back to the moon is radioactive, and without any natural or it, the surface of the moon will remain constant, although unfortunately the words of the radiation will decay to a level comprehension to cosmic rays about a year. In conclusion, we can say with confidence that while the moon itself does not care about being neat and will barely notice. Using the moon as a nuclear test ground kind of ruins it for everyone trying to spend sometimes or doing something useful. So maybe we shouldn't. So that's the end of my video, and goodbye.